in this lesson, before we get to compositions of functions in which we're taking multiple relationships and functions and throwing them together, in the first part of this lesson, we're adding functions together, subtracting them, multiplying them, dividing them, and it's just making sure that you're very, very careful with your operations and very, very careful with your domains. Okay, so in part 1a, I'm being asked for both of them to find the sum, difference, product, and quotient of the two functions. Okay, so f plus g of x, just adding functions together. So I have x minus 4 plus the square root of 9 minus x squared. I noticed on the assignment quiz from functions or from another assignment that some students are looking at that square root of 9 minus x squared and thinking that you can simplify that to 3 minus x. Let me say this now. No, 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 don't do that. It doesn't work. If it was 9 times x squared, that'd be a different story. But in this particular instance, because we are subtracting them, you can't just take the square root of the two things and think that it works out okay. It doesn't. In this particular problem, though, I'm only being asked to add these two things together. I have no like terms to combine. I'm done. The f minus g of x is x minus 4 minus the square root of 9 minus x squared. The product of these is x minus 4 times square root of 9 minus x squared. If you really wanted to, you could distribute that out. I don't think it's really necessary. And the f over g of x is x minus 4 over the square root of 9 minus x squared. Then they're also asking us for the domain of each new function. And what I'd hope that you'd realize is that the restriction on our domain has to do with that square root. Remember that you cannot take the square root of a negative number. Okay? So for all of these, what we need to figure out is what values of x are safe in keeping us from trying to take the square root of a negative number. Okay, so I need 9 minus x squared to be greater than or equal to 0. So that means that 9 has to be greater than or equal to x squared. And sometimes it's hard to tell how the inequalities work when you're taking the square root in order to solve for x. So maybe thinking about it on the number line would help. I know that there's a 3 and I know that there's a negative 3 because that's what the square root of 9 is. But I need, let me flip this around so that it makes more sense, x squared to be less than or equal to 9. So there's 3 and negative 3. I need to consider what intervals, possibly, on the number line make this inequality true. So let me consider a number on this left side of my number line. Let me consider negative 4. And if I take that negative 4 and put it into my inequality, negative 4 times negative 4 is positive 16, and positive 16 is not less than or equal to 9. Then I plug in a number in the next interval of my number line. I can plug in 0. If I take 0 and square it, it's 0, and 0 is less than or equal to 9. So I know that the interval in here will make my statement true. And you might already be guessing, okay, well that means that the other interval isn't. And you'd be right, but let's talk through it. If I take a number on that interval of my number line, I might take 4, and if I take 4 and square it, I get 16, and 16 is not less than or equal to 9. So my domain is restricted to this. My domain is the interval from -3 to +3. In the quotient one, however, I have the added restriction of that 9 minus x squared being in the denominator. So it can't equal 0. Well, that's not too difficult to fix. My domain would have the same boundaries, it just can't equal the -3 and it can't equal the +3. But it's a very similar domain. And that's all part A. We haven't gotten to part B yet. You might want to pause the video and make sure that you have everything for part A before I erase to do part B. In part B, once again, we're adding, subtracting, multiplying, and dividing these functions. So f plus g of x is x squared minus 6x minus 8 plus the square root of x. F minus g of x, just subtracting them this time, x squared minus 6x minus 8 minus the square root of x. Multiplying them, I would have the x squared minus 6x minus 8 multiplying by the square root of x. And finally, quotient f over g of x is x squared minus 6x minus 8 over the square root of x. Once again, in identifying the domain of our graph, we might notice the square root. And there's nothing fancy going on in that square root, it's just x. So I need to make sure, again, let me be clear, that for these, x needs to be greater than or equal to 0. So that would be my domain. If I wanted to express it in interval notation, you could certainly do that. Closed boundary at 0, going to infinity. For the quotient one, once again, I have the added restriction that I'm dividing by that square root of x, so I can't divide by 0, and my domain is, once again, pretty easy to fix. Instead of greater than or equal to 0, x would just be greater than 0, and I could write this in interval notation as open boundary at 0, going to positive infinity. From operations with functions, we move on to compositions of functions, where we're taking one function and inputting it into another. So in example 2, you see that the instructions are asking us to find the f of g of x, the g of f of x, and then find the f of g of a value. And one thing that you want to be mindful of is order. So in this notation that you see on your screen, it looks like it's saying FOG, like fog. What it means, another way to look at it, is I'm being asked to find the f of g of x. And so thinking about it this way might help keep the order proper. So I'm going to take the f of g of x, which means I'm going to take g of x and plug it in for x. So I'm finding the f of 5 minus x squared. And now I'm going to take that 5 minus x squared and plug it in for x in this function. So that's going to equal 3 times 5 minus x squared plus 1. And then I just simplify it as far as I can. This becomes 15 minus 3x squared plus 1. I can combine my like terms and get negative 3x squared plus 16. And that's the f of g of x. They're also asking me to find the g of f of x. So, as I mentioned earlier, that means I'm trying to find the g of f of x. So I'm finding the g of 3x plus 1, which means now I'm going to take that 3x plus 1 and substitute it in for x here into g of x. So this will become 5 minus 3x plus 1 quantity squared. And what you want to be mindful here is do not just square the 3x and square the 1 and think that you're fine and dandy. Remember what it means to square something. You're multiplying it by itself. So that is 5 minus the quantity 3x plus 1 times the quantity 3x plus 1. And hopefully, as you see those two binomials in parentheses next to each other, you realize, oh yeah, FOIL. So we have to FOIL that. We get 5 minus 9x squared plus 3x plus 3x plus 1. And when I combine all of my like terms very carefully with regards to that negative sign in front, I have negative 9x squared minus 6x plus 4. Finally, they're also asking me for the f of g of 3. Well, I previously found here the f of g of x. So if I'm being asked for the f of g of 3, all I have to do is take 3 and plug it into that expression that I've circled. So the f of g of 3 is negative 3 times 3 squared plus 16. And one mistake that I've seen some of you make in expressions like this is you're multiplying the negative 3 outside the parentheses times the 3 that's in the parentheses and then squaring that. That is a misuse of order of operations. Order of operations, it says do your exponent first. And what is being raised to my power here is just the 3 that's in parentheses. So I have negative 3 times 9, which is negative 27. And negative 27 plus 16 is negative 11. And I'm going to pause myself. You might want to pause the video to make sure you have everything from this screen for part A, because I'll need to erase it in order to do part B. In part B, once again, they're asking us for the f of g of x, the g of f of x, and then the f of g of 3. So the f of g of x means that I'm taking the f of x plus 2, which means I'm taking x plus 2 and plugging it in for x in my f function. So I'll have 6 times x plus 2 squared minus 4. And just like we did in the last example, make sure that you realize that this binomial in parentheses needs to get FOILed when you square it. So perhaps writing it out would help. This becomes 6 times x plus 2 times x plus 2 minus 4. So I'll have 6 times what I get when I FOIL the x plus 2 times x plus 2, which is x squared plus 4x plus 4. If you're confused about where I got the 4x from, that's from combining my inner and my outer. 2x plus 2x gives me that 4x. And then I have the minus 4 that I'm bringing down. I distribute the 6, 6x squared plus 24x plus 24 minus 4. And finally, I can combine like terms to get my answer, which is 6x squared plus 24x plus 20. And that's my f of g of x. When I'm trying to find my g of f of x, I'm taking the g of 6x squared minus 4, which means I'm taking that 6x squared minus 4 and plugging it in for x in my g of x function. So this will become 6x squared minus 4 plus 2. And that simplifies much more easily. 6x squared minus 2 is my g of f of x. Finally, the last thing that they're asking us for here is the f of g of 3. Once again, I found here the f of g of x. So in order to find the f of g of 3, I just need to take 3 and plug it into that. So I'll have 6 times 3 squared plus 24 times 3 plus 20. So that's 6 times 9, which is 54, plus 72, plus 20, equaling 146. And I'll pause a moment before I change screens so you can make sure you have everything you need from here. Here they're asking us, once again, to find the f of g. But notice that the instructions for the example say, find a composite function with a restricted domain. And previously, we tried to refresh our memory on what can we look at in an equation in order to decide how a domain is restricted. Okay, so looking at f of x, has a domain restriction, because we know that x plus 1 must be greater than 0. So x therefore has to be greater than -1. My g of x has no domain restriction. I can take any number in the whole wide world and square it and subtract 1 from it, and I'm not going to open a mathematical black hole. Okay, so I make sure that I have my domain restriction in mind when I go ahead and do the exact same thing that we just finished doing in the last screen. The f of g of x means that I'm taking the f of x squared minus 1. So that means I'm taking that x squared minus 1 and plugging it in for x. So that'll be the square root of x squared minus 1 plus 1. And oh, this is very interesting because it ends up being the square root of x squared, which I would hope you'd realize is just x. But even though this composite function would appear to have no restrictions on its domain, you still have a restricted domain because of where this function came from. So my f of g of x is x, but x must be greater than or equal to -1. You have to state that domain in your composite function because it is no longer obvious as I look at the function, but that domain restriction kind of carries over because of where this composite function came from. Similar idea in part 3b. G of x has no restrictions, f of x does. Okay, so f of x domain is that x cannot equal 0. So now let's go ahead and do the rest of it. Finding the f of g of x means that I'm taking the f of x squared plus x and plugging that into my f of x function. So that'll become 5 over x squared plus x. We know from the original domain that x cannot equal 0, but we have to consider that there's additional restriction going on here. So x squared plus x cannot equal 0. So that means that x times x plus 1, because I've factored the x out of this expression, cannot equal 0. Okay, so x can't equal 0. That's still true. But in addition to that, x cannot equal -1. So that's an additional restriction to our domain. In this last example, we're looking at this real-world situation and trying to create a function for it. So this computer store is offering a 15% discount to college students on the purchase of a computer, and they also have a $100 coupon. So let's write a function to model the data. So maybe f of x is representing the 15% discount, so that would be 0.85 x. So that's how much I would be paying for it. Let's remember what I did, because certainly you've seen this before. If I only did 0.15x as my function, I wouldn't be finding the amount of money that I'm spending on my computer. I'd be spending the amount discounted from my computer. Okay, so that's why I subtracted 15% from 100% to get this 85% that I'm expressing as a decimal. Okay, so I just wanted to make sure to clarify that. Oh, also, I just realized they want us using C and D, so that's easy to fix. So C of x equals 0.85x, and D of x I'm going to use to represent the $100 coupon. So that's the price minus 100. That's part A of the problem. In part B, they're asking us to compose the two functions. So finding the C of D of X, that becomes the C of X minus 100, which means I'm taking 0.85 times X minus 100. Going in the opposite direction, D of C of X means I'm taking the D of 0.85x. So that means I have 0.85x minus 100. And they're asking us, what does each composite function represent? Well, what I'd hope that you'd ask yourself at some point in the first steps of this problem is, they're not telling me in what order these two prices off of my computer happen. Because certainly, somewhere along the line, I'm going to be saving money by doing it one way compared to another. And so that's what they're asking us in part C, is to figure out which composition results in a lower price. Well, in the D of C of X, that's as simplified as it gets, but I didn't actually simplify the C of D of X, so let's go ahead and do that now. This one becomes 0.85x minus 85. And so in the composite function on the left, I'm taking 85% of the price and subtracting $85 from it, compared to in the composite function on the right, where I'm taking 85% of the original price and subtracting $100 from it. Well, no matter what x is, this part of it is the same. But in one of them, I'm subtracting another 100, and in the first one, I'm subtracting 85. So I would hope that it makes sense to you that D of x is the better deal. So what does that mean? For us to be doing the D of x, they're taking the 15% off discount first, and then using the $100 coupon.